I've got a couple, only two sapling problems that I want to go over with you. This one is different than mechanisms that we did in section 20.5. This particular one is asking you to draw the mechanism for the conversion from an imine to, down here underneath this box, it says down here it wants the enamine. So it is possible to tautomerize back and forth between the imine and the enamine. And this problem actually isn't that bad because you know what it is that you're trying to make. And there's a lot of hints as you go along the way in terms of helping you decide what each step would look like. So from going from the first box to the second box, what I'm looking at is what kind of things have changed about the molecule. And I can see that I did, in between the first and second step, there is an extra hydrogen on the nitrogen. So I know the first step is going to be protonation of the nitrogen. And that's all that's going on in terms of curved arrows, and that's all that you need in the first box. So when you get over here to the second box, the first thing that you should do is fix the structure that has been provided to you. Because you have a nitrogen with 4 bonds on it, you know that it's going to need to have a positive formal charge, but that's the only thing about the structure that you need to fix. So in terms of curved arrows, looking from the second box to the third box and trying to figure out what's going on, notice that this is a resonance thing. It's not an actual reaction. So what we want to do is draw a resonance structure for the molecule in box number 2. And we've got this double bond next to a positive formal charge. So the most logical resonance structure is going to be to move one of those pairs of electrons onto the nitrogen. And so when we get down to box number 3, again, first thing we have to do is fix the structure. The resonance structure, when we moved the electrons from the double bond over to the nitrogen, we left that carbon with a positive formal charge. So we've got to fix that. And then in terms of curved arrows, we have to figure out how to go from box number 3 to box number 4. And so if we look at what has changed in this situation, we've gone from 3 carbons down to 2 carbons using this conjugate base. And that, I'm drawing my electrons going the wrong way. That is, remember, we're trying to make an enamine, so that is going to give us down here the enamine. Now, underneath all of this, it asks you to make a prediction about what is more stable, the imine versus the enamine, which is more stable. And you can use the same rules that you would use to determine stability of alkene. Even though this is a carbon-nitrogen double bond and it's not an alkene, still apply the same type of rules in terms of how substituted is the double bond to help you answer that question. The other problem that I want to look at with you is this one right here. So I did this problem, and there's actually quite a few problems that are like this, that have, these are retrosynthesis problems. So they're giving you either an imine or an enamine, and they're asking you to draw the products of the reaction. So that would mean that you need to draw either an aldehyde or a ketone, and you need to draw an amine. And so let's just kind of do a refresher on how I told you to go about solving this problem in class. So I said if you have an enamine, the first thing that you should do is move the carbon-carbon double bond up to the carbon-nitrogen double bond spot, because it's going to make it easier for you to visualize the products of the reaction. And then break that carbon-nitrogen double bond, stick an oxygen onto the double bond because we're trying to make a carbonyl compound, so there's that guy right there. Stick a hydrogen on the nitrogen, so there's that guy right there. The other hydrogen that's getting added is getting added to this carbon, which only had one hydrogen, only had one hydrogen. Now we're adding hydrogen number 2. And as you can see, so I did that and I got this problem wrong, and I was like, what the heck? And then I realized that when this reaction takes place and it's in acidic solution, the product is an amine. Amines are bases, which means that if you have amines in an acidic solution, they are going to get protonated by that acid. So the actual product that Sapling wants you to draw is the protonated amine. In this case, 2 hydrogens and a positive charge. This is the correct structure of the amine. And also this is correct as well. And so you have several of these, like I want to say maybe 4 problems that are like this, where it's asking you to draw the products of these reactions in acidic solution. Make sure that you are always protonating your nitrogen and putting a positive formal charge on it. That's what Sapling wants from you.